Today we're talking about AND gates. And AND gates are very useful, and we use the word AND in sentences, and AND gates are just about as useful in electronics as the word AND is in our vocabulary. And, man, I just like saying the word AND. So we got schematic and we got circuit. So, yep. Alright, so before we do the circuit, we gotta do theory. We have to know how it works. So, this is an AND gate, and it is what's called it's part of a family called the logic gates. And what they do is they analyze input from the input lines, and they send their analysis on the output line. And so what this thing does is actually really simple. This input and this input have to have stuff on them. We'll call them ones. And so, like, there's a 1 on this input line. There's a 1 on that input line. And both inputs have to have a 1. So this and this one have to have a 1. And what happens is, like, all right, if that's the case, then we're going to put a 1 on the output. And if there's not 1 on this and this, then it don't get a 1 over here. So if there was what's called a 0 and a 0, be like, what? Well, nope and nope. So no, there's a 0 over here. Both of these have to be true. Any other combination means that this is going to be a 0. This is only like, if this answers the question, is this and this both 1? Yes. If it's not true, then this is going to be a 0. And this is set up with what's called a truth table. And suppose instead of having input, they're not twins anymore. We'll just fix that. If this was A and this was B, and instead of output it was Y, and we set up like a truth table, so you had like A, B, Y, and you like did it for all the possibilities, like if they were both 0, and if one was 1 and one was 0, or if the other was 1, the other was 0, or if they're both on. The AND gates truth table, this is what it's called, it's a truth table. The only time this will be a 1, only time Y, the output, will have a 1, is when they're both 1. And so A and B is what Y is. In Boolean algebra, which is like people have a whole bunch of these AND gates. Like in your computer, you got like OR gates and AND gates and XOR gates and NOR gates and NOT gates. There's a whole bunch of stuff. And instead of memorizing and all that, they came up with equations. And so the equation, if you will, for an AND gate, Y, can you see that? No, you can't. We'll write it down here. Y equals A times B. If you use, if you've never seen a dot before, the dot means times, multiplication. And so the output is going to be A times B. So if anything times 0 is going to be 0. So like 57.9 times 0 equals 0. And we could do this all day. Anything times 0 is going to be 0. And so if, let's just rewrite this, we'll say Y equals 1 times 0. So like A was 1 and B was 0. Y is going to be 0 because 0 times anything is 0. So yes, that is like the equation, Boolean algebra right there. Google it. Moving on to electronics. How do we wire this? Well, a logic 1, which is what we've been talking about, 1 equals, it's a little bit more complex, but that's what you need to know. Logic 1 equals 5 volts. Logic 0 equals 0 volts. So like if we redid the AND gate, if we have 5 volts here, 5 volts here, we have 5 volts out here because this has 5 volts and this has 5 volts. So that means like this satisfies the AND gate. They're like, AND gate's like, yay, they're both high, they're both 1s, then it's going to output 1 to here. If this was 0 volts, then 5 is 0 because this and that, not both turned on. So that's 0. Alright, so here's the electrical schematic for the circuit that we're going to build. And this circuit right here, it takes 9-volt battery and it basically converts it into 5 volts so that we can have a nice little steady output voltage. And if you don't know what I'm talking about and you want to find out, go ahead and look at some of my other videos. But if you do know what I'm talking about, then or you just want to pretend like you know what I'm talking about and you think it'll be alright, because it will, just keep watching. And but what we're really interested is this circuit right here. Alright, so this circuit right here is what it takes to talk to an AND gate. And it is like this circuit right here. Like this part right here is the voltage regulator. Everything else is this circuit. And so I'll go ahead and explain some stuff. Right here is the AND gate, and it has 74XX08 or 08. And what that right there is like the model number of the integrated circuit used. Looks like this. And the reason there's like XX there, that means it can be anything. What's normally there is like HC or LS or LV, and those are like kind of families of integrated circuits, but all across the board, if it's 7408, that means that it's going to be an AND gate and it's going to have the same pinouts. These numbers right here, that talks about the individual pins, so you know where to hook it up, because this thing, it's got 14 connections, and 1, 2, 3, 4, there's only 5 connections on this thing, so which ones do you pick? Well, the cool thing is this integrated circuit actually has 4 AND gates, so it's special. And we're just going to use 1. So that's that part. And you can see it's got these lines that go up to this thing called 5V. That's the 5 volt thing. So on the other circuit, that means that hook it up to 5 volts, and you get 5 volts out of the other circuit. All the 5 volt connections are along this little thing. It's called a bus, and so all of these red wires, they're actually connected together, and that's 5 volts right there. And so this is the integrated circuit that's got the AND gate in it, and it's got a wire going from the 5 volt line to that pin. That pin is 14. As you can see, 14 is connected to 5 volts. So that's all good. And they got 5 volts over here, 5 volts here. This thing is called ground. That is kind of synonymous with the negative side of your battery. As you can, this right here is just a battery adapter. It like plugs right in. It's actually, well, there we go. And the black wire is like connected to the negative side of the battery, this side, and it's connected to the opposite bus, black stuff, and that is like the negative side of the battery. And so all these little dash things, that is where that's called a ground connection, and that's where the stuff is connected to the negative side of the battery. So you can see, back to the AND gate, this black wire right there is connected from that pin 7 on the AND gate. It's going to ground. So just like this shows. This thing right here, that is called a light emitting diode. You can tell it's a light emitting diode because it's got the arrows pointing out. That means it's like emitting light. And so that's that. And you got resistors and switches or buttons. So yeah, let's go ahead and build this thing. Alright, so some people might have these like long jumper wires, and you can use those, but I will be using kind of a shorter, more compact wire. So yeah, just keep in mind, it's all the same, it's still metal, it still conducts, it's not like it's fiber optics or anything. But first thing you want to do is put a nice little wire. I'm going to use a black wire, but it doesn't matter. Second row from the top, which bridges from the ground bus all the way to the to a terminal strip. I'm going to put another black wire which connects over the channel, because like this channel, it separates stuff on each one of these rows. It separates the whole stuff. You want to grab a 7805 voltage regulator. It'll say it right on the front, and you want to stick it so that the back, the flat side, is toward the channel all the way on the top. So the black wire will be on the same row of holes as the middle leg on the on this integrated circuit. Next, you want to grab a 10 microfarad capacitor. This can focus on it. You want to locate the stripe, and you want the leg next to the stripe to be closest, to be on that same row of middle holes. So on this, the stripe is down, the non-stripe side is up, and the legs are there. It's all, this is at the top. So if my two fingers, like the tips of my two fingers were the legs, they're going like this, not like that. So make them go like this. Next, you want to get another capacitor, and this is a 100 microfarad capacitor. Go ahead and locate the stripe. The stripe goes, the leg with the stripe, or the leg next to the stripe, goes on the same hole as the other capacitor's stripe leg. And so this one, the stripe will go up, that one, the stripe's going down. And insert it. There should be one hole above the second capacitor, like so. Awesome. Oh, forgot a step. All right, so go ahead and locate a red wire and insert it on the very top row of holes, like so. And so this is like the output. This is the output of the voltage regulator is outputting 5 volts, and so we're gonna have 5 volts all across there. Go ahead and grab a 100 microfarad capacitor, and you'll know it's 100 microfarad because it says 100, and then it's got the Greek letter mu, I think it is, and then it has a capital F, and so you know it's 100 microfarad. There is all of these kind of a Coke bottle, well, Coke can capacitors have this stripe, and that stripe saying hook that side up, hook the leg next to the stripe, hook that up to ground. And on here, ground is marked with the black, and it goes from this strip all the way over here. So it's on the second row of holes, and so we can hook the stripe leg right up to there. So the stripe's on the top, other side's, you know, not there. And go ahead and get the other capacitor. This is a 10 microfarad capacitor. Locate the stripe. So once again, the leg with the next to the stripe needs to go in that second to top row of holes. This capacitor is all the way at the top. The bigger one is below the red wire. Alright, so this is the voltage regulator circuit. It takes output from this 9-volt battery, which this 9-volt battery could be good, it could be bad, like it could be dead-ish. This doesn't care. It's going to say, well, as long as as long as this battery is kind of good, like it's not like completely dead, like you can't just hook up a block of wood to this and have it output 5 volts. Like you can't just get voltage out of nothing. But as long as this is kind of good, then this makes it the same. This makes it 5 volts when the power gets over here. This is always going to be 5 volts, whether this is a really, really, really good battery or not so much. So, next thing we have to do is have to insert the actual chip. Now, I'm using the 74HC08. You can use the LS08 or the LV08. I got the HC, and that means it's the CMOS version, which can run on lower voltages if I want it. I am aligning it so this little circle and this divot is at the top. That's called the notch, and that should always be at the top. Like if you see some person's board and they've got the notch at the bottom, they might need glasses. Don't worry, I have glasses too. I'm not offended, and I hope you aren't. That top leg is in line with the second group of 5 holes. And the first thing we're going to do is hook up power, because our integrated circuit needs power. And so I got a red wire going right there. Next thing we need is a ground connection, because, well, that's just about what everything needs. And that is... Whoops, I bent it. Alright. Just like so. So this is the very bottom a pin on the left, the very top pin on the right. And this is a pretty standard configuration for like power and ground. Like if you had one guess, like if someone kidnapped you and said, alright, I'm gonna kill you unless you can guess the correct power and ground for a given integrated circuit. This is a pretty good guess. That would be my guess. Not that anyone would ever get kidnapped and sent to, I mean, that's pretty outrageous, but that's what we do. We think of outrageous things. Next, you want, well, I'm telling you, put a connection like so, and this is going to be for our buttons, because our buttons are going to need to route power, like on our schematic. The S1 and S2, those are like buttons. So like your finger like presses down and that little lever goes and makes a connection there. And they're connected to 5 volts. So we need to put stuff there. And the next one is like so. Now, we have the buttons, and how they are is when the legs coming out are on the sides as opposed to the top and bottom, the 2 bottom ones are connected together and the 2 top legs are connected together. And when you press the button, the top 2 are connected to the 2 bottom, or the bottom 2. And that's how the switches like work internally. That's the guts of it. And I'll go ahead, put one right so that there's no room between the integrated circuit and the button. It's all there. And the other one, like so. So the power is connected to the bottom leg of each switch respectively, or button. I don't know. I think of it as a switch that has a little spring in it, but people say buttons. If you look on the schematic, one end of the switch is connected to 5 volts, of the switches are connected to 5 volts. The other end is connected to the AND gates, or the AND gate, and also to a resistor and then to ground. And this is called a pull-down resistor. And what it does is it kind of sets the default condition of the AND gate. AND gates, like their inputs, if you just don't give them anything, like if you just leave them alone, you don't give them a 1 or a 0, you don't connect it to 0 volts and you don't connect it to 5 volts, then bad things happen. It can't make up its mind what to do. And so we need to insert these resistors. These are brown, black, orange, gold resistors, which means they're 10k ohm resistors, and the tolerance, or like how accurate that rating actually is it is plus or minus 5%. And that is the, oh, no, that's right. That is like where the gold comes in. If that was, if it was silver, it's not quite as good. Alright, so, and these resistors are on the top of the switches, like that's the top row of legs, power's the bottom row of legs. Alright, so that's cool. We just have to hook up the switches to the AND gate and then do the LED circuit, because like, if we just did the buttons, we wouldn't know if it really worked, because we couldn't, I mean, we can't really see voltage going, or current going through stuff. We have to have things like lights and speakers and buzzers and tasers to show us what's actually going on. Alright, so what we're going to do is gonna take another wire, and yellow just means it's different. I mean, it's just, it doesn't even have to be different, but it has to connect to get the connection right. That's what. Yes, this is right. So it goes from the same row of holes as that resistor, and the top of the button goes all the way to the middle hole, or 4, on the integrated circuit. So you can see pin 4 is connected to S2. So I guess this one's S2. It really doesn't make a difference because well, both of them have to be on. It's not like one's special and it turns the circuit on. No, it's like a team effort. Remember, there's no I in team, so there's no one switch that can do the job. It's a team effort. And the other one we'll just do like so. And so it's this second yellow wire goes from that 10 k ohm resistor, the other 10 k ohm resistor rather, to the pin 5, and like so. So we got the inputs all hooked up, but now we need the output, and then we'll need power. So we are going to start, we're going to start backwards. So here's ground, and here's R3. R3 is a 220 ohm resistor. And so that looks like this. This is a red, red, brown, gold, and that is 220 ohms, plus or minus 5%. So I got that right at the bottom. Next thing you want to do is you want to get an LED, and this one's just kind of a boring green one, but it could be like, you know, really cool, really fancy, but it just has to be an LED. I've trimmed the legs on mine, but the short leg is still the short leg and the long leg is still the long leg. The short leg is the that's that side, and the long leg is the other side. And this is really important because the diode is, its official name is a light emitting diode, D1, light emitting diode. And the diode part, that means it's a one-way gate. And so it's not going to work if we put it the wrong way. So short leg is goes toward the bottom, and the longer leg goes in the row of holes above it, like so. So you, like when you pull that out, and same for the capacitors too. Like so. Like if it was the other way, so that both pins were going into the same hole, that not work. We want it like so. Alright, and then we'll just take a wire, and this is a little complicated. You have to get the wire right in the second to last hole. I gotta get my camera to focus. Second to last hole, so pin 6, yep, there we go, pin 6, and the other end goes like so. And so it's not on, the same row as the resistor. All right, so last but not least, because it wouldn't work without it, power. What you can do is the red wire goes to the third from the top hole, like so. And the black wire can go anywhere along here. Alright, so that's cool. And then hook up the 9 volt. And then basically both buttons have to be pressed for this, like both buttons have to be pressed for the AND gate to say yes, both inputs are 1, and then it will show the light. So like if we press one button, not doing anything, press the other button, not doing anything, but if I press both, nothing happens. Great. Alright, and here's the finished product. So, since it's an AND gate, both buttons have to be pressed, like one button and the other button. So like, pressing this one's not going to do a whole lot, pressing that one's not going to do a whole lot, but both together makes the light go on. So yeah, I hope this video makes sense, and yeah,